Hello everyone, you are welcome to the GMAT41's YouTube channel. In this video, I have this question I want to quickly solve. Okay, we are required to simplify cos 2x minus 1 all over cos 2x plus 1. A clear look at this question, you see clearly that it is a trigonometric identity problem. Okay, a question obtained from trigonometry. Alright, please remember to subscribe to the GMAT41's YouTube channel and turn on the notification bell so that once I upload any new content, you will be personally notified. We shall solve this question and then see what the option is as given to us in the question. We have cos 2x minus 1 all over cos 2x plus 1. Looking at this function given to us already, we have cos. Okay, so the problem is already in basic trig form. What do we mean by basic trig form? When the problem is given having just sine or cosine and or tangent, if it contains this, we can say that the problem is in its basic form, because sine, cosine and tangent are the first three basic trig functions, and so we cannot talk about breaking these down into another smaller form. And therefore, looking at this problem, the only thing I can do is copying the trig identity for this cos 2x, which of course, from the knowledge of trigonometric identity, this cos 2x is equal to cos square x minus sine square x. So this is the trig identity of cos 2x. And then we're going to do minus 1. Alright? We shall divide it by, we'll do same here, cos 2x, we copy this identity once again, which is cos square x minus sine square x. Then of course this is plus 1. Good. Now looking at this, if you look at the options given to us, we've got tan, alright, tan square, and then we have cos square x. Ordinarily, this cannot be broken down to give you just cos square x left because of all this sine square and then minus 1. So there is no way this C can be the answer. And so I'll be left with trying to resolve this, getting one of this time. That will now be my focus. And how can I resolve this to get tan? This contains sine and cos already, as you can see. And we know from trig identity, the basic form, that tan theta is equal to sine theta over cos theta. So being guided by that identity, I am going to simplify this so that I would have something like sine in the numerator all over cos, alright, in the denominator. That's the only way I can approach this, and of course that is what I am going to do. Since I'm interested in ensuring that I have sine on top and then cos under, so that at least I can get something in the nature of tangent, okay? It means that I would replace this cos square x by its identity once again, alright, or its value. I won't touch this sine square x because I want sine to be in the numerator. Hence, I'll be changing this. Is that okay? I'll be changing this to its value in terms of sine square. Cos square x plus sine square x is equal to 1. Therefore, cos square x in terms of sine will be 1 minus sine square x. So I'll quickly do that right away. Is that okay? This is going to be equal to cos square x 1 minus sine square x, and then minus this sine square x minus 1 all over. In the denominator, remember, I'm targeting cosine in that denominator, so I will maintain this cos square x and then change sine square x to contain cos square x. Remember, from Pythagorean identity, sine square x plus cos square x is equal to 1. I just mentioned it while dealing with the numerator. Therefore, if I want to remove this sine square x and write it in terms of cos square x, it's going to be that sine square x equal to 1 minus cos square x. So let's do that. Maintaining this cos square x, then minus, I'll open bracket, this is going to be 1 minus cos square x, and then plus 1. Alright, I will just simplify this numerator. I'm going to be fast in doing that, please just watch. You know, this bracket, there is invisible plus 1 here, so if you open it up, it will still maintain 1 minus sine square x. and then this is minus sine square x, and then minus 1. Watch something, please. This 1 minus 1 will give you 0, so they go off. And then you have minus sine square x minus sine square x. X is going to give us minus 2 sine square x. So this is equal to, remember already that this 1 minus 1 goes to 0, so it goes off. Now look at the denominator, we'll do the same thing there. If you use this negative, there is negative outside the bracket here. Use it to open up this bracket. This 1 will become minus 1. This minus will change this minus to plus, so you have plus cos square x. So what am I saying in essence? If you open up this bracket, you will have cos square x minus 1 plus cos square x, and then plus 1. This minus 1 from here plus this 1, they are like terms, minus 1 plus 1 will give you 0, so it goes off. And then you have cos square x. Minus minus gives you this cos square x to be plus. So this is cos square x plus cos square x, which will give us 2 cos square x. Correct. Now if you look at this, you'll agree with me that these 2 will cancel out. And of course, once it cancels out, we have negative sine square x all over cos squared x. I'm going to tell you something now. Sine divided by cos would give us tan. And therefore, sine square x all over cos square x would give us tan square x. So we can conclude the problem given to us, cos 2x minus 1 all over cos 2x plus 1 would be equal to this over this is tan square x, and you've got minus there, and so that is going to be minus tan squared x. And of course, this is the simplified form of this trigonometric function given to us. And you would agree with me clearly that the result here tells us that, okay, this is option D, alright? Tells us that option D is the correct answer. I'm going to say this quickly. In theoretical case, that's the case of theory, for example, you might simply be asked, prove that this is equal to this. And what you saw me do here is exactly how you approach the problem. It's alright, friends, I hope you enjoyed this video lesson, just a quick one. If you do, remember to subscribe to our channel as I've appeared to you, and then of course invite your friends to do the same. You can join our classes, alright, online, and if you are in UNIZIK, Nnamdi Azikiwe University, Awka, if you still wish to join our physical tutorials, you can always do that. Contact us using the number showing on the screen in order to join our physical tutorial classes. I'll be seeing you in our next video lesson.